Okay, let's unpack this. Get this. Modern AI, running on a computer from 1997.
Sounds wild, right?
Totally. We're talking Windows 98, Pentium II processor, just 128 megabytes of RAM.
It seems impossible on this surface.
How did they even pull that off? Let's dive in and find out.
Yeah, this experiment by ExoLabs, which, Andrej Karpathy founded, is pretty remarkable.
ExoLabs, right.
Getting something like Llama 2, a modern large language model, to work on hardware that old, it really stretches what we think is needed for AI.
It really does. We always hear about needing more power, faster chips, so this just flips that narrative. What were the first hurdles? I mean, just physically getting things to work on a 97 machine?
Well, yeah, the basic stuff was surprisingly tricky. First off, no USB ports.
Oh, right, of course.
So they had to dig out old PS2 keyboards and mice. Remember those?
Vaguely. So, okay, input sorted. How did they get the actual AI model and code onto it? No USB stick.
Exactly. And the file system, FET32, had limitations too. They ended up using FTP.
FTP. Seriously. Like file transfer protocol.
Yep. Hooked up an Ethernet cable between the old PC and a modern MacBook Pro and just transferred the files, model weights, tokenizer, the inference code itself.
That is a proper retro solution.
Yeah.
Okay, files are on the machine. But running modern code, compiling it, the processor instructions must be completely different.
That was the next big challenge. Modern compilers just wouldn't work. The executables they produced use instructions that Pentium II didn't understand.
Makes sense.
So they went even more retro. They used Borland C plus 5.02.
Borland. Wow. Okay. That takes me back.
Yeah, 26-year-old compiler specifically compatible with Windows 98.
Incredible.
And they took Andrej Karpathy's Llama 2.c code, which is already known for being incredibly efficient, like super lean, just 700 lines of C, and adapted it slightly to work with the older C standards that Borland C++ understood.
So old compiler meets lean, optimized modern code. Clever.
Very. And this Llama 2.c was really crucial. It's designed for inference, just running the model efficiently.
Right. And did it actually work? How fast was it?
It did. They successfully ran a model with 260,000 parameters.
Okay.
And achieved 39.31 tokens per second.
39 tokens a second. That's actually not bad at all for that hardware. A token is roughly a word or part of a word, right?
Pretty much. So it was generating text at a usable speed. They tried bigger models too, but obviously it got slower.
Still, that's impressive. What was the secret sauce in the AI model itself?
260K parameters is small, but still.
Ah, yes. This is where the other key piece comes in. BitNet.
BitNet.
It's a newer type of transformer architecture that ExoLabs is working on. The big difference is how it handles the model's weights.
Okay.
Traditional models use, complex floating point numbers, very precise, but computationally heavy.
Right, and use lots of power.
BitNet uses ternary weights.
Okay.
Meaning each weight can only be one of three values. -1, 0, +1.
That's it? -1, 0, or 1.
That's it. This makes the model dramatically smaller and much, much easier to compute. I can see how that would help. How much smaller are we talking?
Well, for example, they mentioned a 7 billion parameter BitNet model needing only about 1.38 gigabytes.
Wow. Compared to tens or hundreds of digs for traditional models of that size.
Exactly. And crucially, this ternary approach doesn't just save space. It fundamentally changes the math. It's much less demanding on the processor. It's designed to be CPU first, not needing powerful GPUs as much.
So that's the other half of the magic, efficient C code, plus the super efficient BitNet model architecture using simple weights.
Precisely.
Yeah.
It sidesteps the need for that bleeding edge hardware.
Okay, so it's a cool tech demo, but what does this mean for, us, for you listening? Why should we care about AI on a vintage PC?
Well, I think there are a couple of big takeaways here. First, it really questions that assumption that AI always needs bigger, faster hardware.
Right. It shows optimization is key.
Hugely important. Algorithmic improvements can be just as impactful, maybe more so sometimes, than just throwing more power at the problem. Second, think about accessibility. If you can run useful AI on older, less powerful devices, imagine the possibilities.
Yeah, like in places with limited resources or just reusing older tech we already have.
Exactly. Developing countries, schools, even just extending the life of your own older laptop or phone. It could really democratize access to AI tools.
And this aligns with what ExoLabs is about.
Very much so. They were founded just last July 2024, and their focus is AI education and accessibility.
Makes sense given Karpathy's background too.
Right. Their first product is actually an online course, LLM 101N, teaching people how to build their own AI assistants.
Cool.
And they're also developing software for distributed AI inference.
Yeah.
The idea is to pool the computing power of lots of everyday devices together to run bigger models, kind of like a network version of this old PC experiment.
Combining resources. Interesting. So, okay, to sum up, they ran Llama 2 on a 97 Pentium II with 128 millibit RAM.
Using PS2 FTP for setup, and crucially, Borland C++ with Karpathy's Llama 2.c.
And the bitnet architecture with those simple ternary weights was a game changer for efficiency.
Definitely. They got nearly 40 tokens per second on a 260K parameter model.
Showing that AI can run on much older hardware, opening doors for accessibility and sustainability.
And highlighting that software optimization is just as vital as hardware muscle.
It really makes you think, doesn't it? If AI can be tweaked to run on something that old, what other tech limitations do we assume are hardware problems when maybe, just maybe, there's software challenges waiting for a clever solution?
It definitely shifts the perspective. What else could be possible if we rethink how software interacts with the devices we already own?
A lot to ponder there. Really fascinating stuff.
Absolutely.
And hey, if you enjoyed this deep dive into AI running on vintage tech, definitely check out Le Podcast de Philippe. We're trying to hit 1,000 subscribers, so every listen helps.